Welcome to JSS RSHPU Physics channel. Today we are going to perform refractive index of glass slab. Here the aim is to determine the refractive index of a glass slab using a traveling microscope. The apparatus required are a traveling microscope, glass slab, a magnifying lens and a wooden powder. So for the first we are going to check with the observations. Here is a traveling microscope. In this we have a main scale as well as a vernier scale. So here if you just turn on the right, see this is the main scale just like your centimeter scale. In centimeter scale from 0 to 1 you have 10 divisions. Here you have 20 divisions. So 1 centimeter divided by 20 will give you 0.05 centimeter. So the value of 1 MSD is 0.05 centimeter. Now vernier scale from 0 to 1 there are 10 divisions. So from 0 to 5 there are 50 divisions. So the total number of divisions on vernier scale is 50. So I will write in the observation table n is equal to 50. So to find the least count of the traveling microscope, value of 1 MSD divided by total number of divisions on vernier scale, that is n. So 0.05 divided by 50 will give you 0.001 centimeter, which is the least count of the traveling microscope. Initially, to take the first reading, we have to focus this microscope on the graph sheet. So if the graph sheet is not clear, make a ink mark on that. So here, this is called as rack and pinion adjustment. It should be constant throughout the experiment. Initially, you can set it. Once you start, you cannot touch it. So now, with the help of this course adjustment, so we have to focus this microscope on the given ink mark. Once you focus it on the ink mark, now come to take the readings. So if the lines are not visible, you can use the magnifying lens, using which the readings become clear. So if you observe here, this is the zeroth division. This is the zeroth division of the vernier scale. If you look at that, it has crossed 3.1. So here the readings goes like 3, 3.05, 3.1, 3.15 like that. So here it has cost 3.1. So note on that first reading. And for the vernier divisions, so out of 50 you can check for like 5, 10, 15, 20, any one, whichever is like most coinciding. Okay, so that division you can mark. Now the calculation goes like, so here the main scale reading is 3.15 centimeter and 10 is the vernier division, coinciding vernier division. So the total reading will be 3.16 centimeter. So I have written here. Now for the second reading, insert the glass slab, and again if you just observe it, so as you have seen now, so initially it was clear. Once I have inserted this glass slab, the image has become blur. So again use the traveling microscope to set the clear image. Okay, so now Now, the second reading should also be taken in the same way. Look at the zeroth vernier division on the main scale where it is coinciding, and again check for the coinciding divisions. So, the reading I have already noted down here. So, the main scale reading is 3.75 and it is exactly coinciding. That's why the CVD is 0. So, the total reading is 3.75 centimeter, which I have noted down here. So, now for the third reading, take few particles of the wooden powder and sprinkle it just below the microscope. Don't take much, the thickness should be very less here. So now again focus on the wooden particles for the third readings. You can see the clear image of the wooden particles now. Again take the readings in a similar way. Here the zeroth division is like 4.95. So now you can check for the CVD. The CVD here is 10. The coinciding vernier division is exactly coinciding with the main scale. So I have rounded readings here. So this is 4.90. The CVD is 10. So the total reading is 4.91 centimeter. So using this, we can calculate. Here this is A1, A2, A3. To find the refractive index, we have to do A3 minus A1 divided by A3 minus A2. A3 minus A1 gives you the thickness of the given glass slab. A3 minus A2 will give you the apparent shift. So the thickness divided by apparent shift will give you the refractive index. Now the same result reading can be written in the result, that gives like the refractive index of the glass slab was found to be 1.51, where NGA is a mean value of the refractive index of glass with respect to the medium air.